Welcome to this comprehensive guide on saving and loading player progress and inventory in Unity 3D using Visual Studio. This tutorial is specifically designed for beginners, aiming to provide a clear, step-by-step approach to implementing robust data persistence in your games. Data persistence is absolutely crucial for any game, as it allows players to save their progress and resume from exactly where they left off. This capability significantly enhances their overall gaming experience, preventing the frustration of losing progress and encouraging continued engagement. It involves storing essential game states such as the player's current position, their health status, accumulated score, and the contents of their inventory. By saving these critical data points, we ensure that players never have to restart from scratch every time they launch the game, making their experience much more enjoyable and seamless. Unity offers several distinct methods for achieving data persistence, each with its own specific use cases, advantages, and inherent limitations. Understanding these different approaches is key to choosing the most appropriate one for your game's needs. Player Prefs is an ideal solution for storing simple settings like audio volume levels or graphics quality preferences. However, it is limited to only float, int, and string data types, making it unsuitable for complex data structures, and it does not offer any inherent security against tampering. JSON Utility, on the other hand, is an excellent choice for managing more complex data, such as intricate game states and detailed player data. It leverages Unity's built-in API for efficient serialization and deserialization, making it a powerful tool for structured data. This method allows for easy management of multiple save files, providing flexibility in how players store their progress. However, it requires that the fields you wish to serialize are public, and it is not a fully featured JSON implementation, which means some advanced JSON features might not be directly supported. Binary Formatter provides a more secure method for data storage by serializing data into a non-human readable binary format. This makes it significantly harder for unauthorized users to tamper with or understand the saved game data, offering an enhanced layer of security. However, a trade-off for this increased security is that Binary Formatter can be slower in performance compared to JSON Utility. Additionally, because the data is not human-readable, debugging can become more complicated, especially for beginners who are still learning the ropes of data persistence. Scriptable objects are particularly useful for creating reusable data containers that can be saved and loaded directly as assets within the Unity editor. They are excellent for managing game configurations, item definitions, or character stats that are not tied to a specific game instance. For the purpose of this tutorial, we will focus specifically on JSON Utility. Its human-readable format and the relative ease of debugging make it an ideal and highly recommended choice for beginners who are just starting to explore data persistence in Unity. Our very first step in this implementation process is to create a Save System class in C# using Visual Studio. This class will serve as the central hub for managing all our saving and loading operations, encapsulating the logic for data persistence. Inside our SaveSystem.cs file, we will need to include several necessary namespaces. These include System for basic system functionalities, System.io for file operations, and Unity Engine for Unity-specific functionalities, ensuring our script has access to all required libraries. Next, we will define two core methods within this SaveSystem class, one specifically designed for saving player data, and another distinct method dedicated to loading that data. These methods will form the backbone of our data persistence system. Data serialization is a fundamental concept here. It is the key process of converting our complex game data, such as player stats and inventory, into a streamlined format that can be easily stored, whether in a file or a database. To define precisely what player information will be stored, we'll create a playerdata.cs script. This script will outline the structure of our saved data, including crucial elements like the player's health, their current score, their in-game position, and a comprehensive list of their inventory items. It is absolutely crucial to mark the player data class with the system serializable attribute. This attribute is essential because it explicitly allows the class to be serialized into a file format, making it possible to save and load instances of this class. Here's a detailed example of our player data class structure, which includes public fields for health as a float, score as an integer, position as a Unity Vector 3, and a list string to hold the player's inventory items. This structure ensures all key player data can be saved. To initiate the saving of player data, our first step is to accurately determine the save file path. We achieve this by utilizing application.persistentDataPath, which provides a reliable and cross-platform compatible directory for storing application-specific data. Subsequently, we create a new instance of our player data class. We then meticulously populate this instance with the player's current game data, ensuring that all relevant information, such as health, score, and position, is accurately captured at the moment of saving. Once our player data object is fully populated, we serialize this object into a JSON string. This is efficiently accomplished using JSON utility.toJSON, which converts the object's public fields into a human-readable JSON format. Finally, after the data has been serialized into a JSON string, we write this string to our chosen file path. This is done using file.writeAllText, which securely stores the player's progress on the disk. Loading player data begins with a critical preliminary step, checking if the save file actually exists. We use file.exist for this purpose, which is vital to prevent potential errors and exceptions that would occur if we tried to read from a non-existent file. If the file is confirmed to exist, we then proceed to read its entire content. This involves using file.readAllText to retrieve the complete JSON string stored within the save file, bringing the saved data into our application. This retrieved JSON string is then deserialized back into a player data object. We accomplish this by using JSON utility.fromJSON player data, which reconstructs our structured player data from the JSON text, making it usable within the game again. Once the data is successfully loaded and deserialized, it is then applied to our active player object. This process updates their health, score, position, and inventory to reflect the state saved in the file, effectively restoring their progress. Now, let's transition to Unity to create a simple user interface. This UI will feature save and load buttons, which will serve as the interactive triggers for our newly implemented saving and loading functionality. We'll attach a script to each of these buttons and meticulously configure their on-click events. This configuration will ensure that when a button is pressed, it correctly calls the respective save player data or load player data methods from our save system class, linking the UI to our backend logic. For inventory saving, if your game system utilizes a list of items, you can conveniently serialize this list directly within your player data class. This approach allows for a straightforward and integrated way to store the player's entire inventory alongside other vital statistics. When designing your inventory saving mechanism, consider storing item codes, unique names, and their respective counts. A dictionary structure can be particularly efficient for this, allowing you to manage and retrieve inventory items quickly and effectively. When loading, the process involves retrieving these stored item codes and counts from the saved data. This information is then used to accurately repopulate the player's inventory, ensuring that all items are restored to their correct state and quantity. Error handling is an absolutely vital component of any robust save system. It is imperative to implement try-catch blocks around your file operations to gracefully manage potential issues, such as file access exceptions or instances of corrupted data, preventing crashes and ensuring a smoother user experience. Always strive to provide clear and informative error messages to the user. These messages are invaluable for aiding in troubleshooting, helping players understand what went wrong, and ultimately improving their overall experience by guiding them towards a solution. Here are some helpful tips specifically for beginners. First and foremost, always structure your data logically. A well-organized data structure makes management significantly easier, reduces complexity, and helps prevent errors as your game grows. It is crucial to thoroughly test your saving and loading functionality under various scenarios. This rigorous testing ensures data integrity, verifies that all data is correctly saved and loaded, and helps prevent unexpected issues or data loss during gameplay. Always make it a practice to create backup save files. This is especially important during the development phase or for critical game states, as backups provide a safety net against accidental data corruption or loss, allowing you to revert to a stable point. For any sensitive data that needs to be stored, consider implementing encryption for your save files. Encrypting the data adds a significant layer of security, preventing unauthorized tampering and protecting player information from being easily modified or accessed. An alternative and highly efficient approach to data persistence is data binding. This technique can significantly speed up save times by maintaining the persistent state of the game in a ready-to-save format, allowing for instant data capture. This method ensures that all the data you intend to persist is known and accessible at all times. Consequently, saving your game state becomes an incredibly fast operation, minimizing any potential delays or hitches during gameplay. By diligently following these comprehensive steps and incorporating the best practices discussed, you will be well equipped to successfully implement robust and reliable saving and loading systems in your Unity games, providing a seamless experience for your players. We encourage you to experiment with these techniques, adapt them to your specific game needs, and continue learning. Happy game development, and may your projects be filled with successful saves and loads.